You know, when you look out deep into space, you see these beautiful, glittering galaxies, and they look so peaceful. But what if I told you that looks can be incredibly deceiving? We're about to dive into the story of one galaxy, IC 2574, that's literally being blown to pieces from the inside out.
Okay, so here it is. This is IC 2574, sometimes called Coddington's Nebula. It's a smaller, dwarf galaxy hanging out in the constellation Ursa Major, about 13 million light-years from us. And at first glance, it's gorgeous, right? You see all those bright blue specks? Those are clusters of super hot young stars. It looks like a perfect little star factory.
But, as you probably guessed, what you see in visible light, that's almost never the whole story in astronomy. Not even close. To get to the real mystery here, we have to look at the stuff that's completely invisible to our eyes.
So astronomers pointed their radio telescopes at it. This time they weren't looking for stars, they were looking for hydrogen gas. You know, the raw fuel that stars are made of. And what they saw, well, it was something else entirely. It wasn't that pretty, smooth galaxy anymore. Honestly, it was a total mess.
Just look at this thing. It's absolutely riddled with holes. Giant empty bubbles and huge cavities have been carved right out of its gas clouds. The very material that should be fueling the next generation of stars has just been blasted away. It is literally a piece of cosmic Swiss cheese.
And we're not talking about a couple of little gaps here. No, astronomers have counted at least 48 distinct holes punched out of this galaxy. And some of them are absolutely colossal. We're talking 1,000 light-years across. It's just mind-bogglingly huge.
So that brings us to the big question, right? The whole reason we're digging into this galaxy. What in the universe is powerful enough to do that? To punch holes clean through an entire galaxy? What's going on here?
Well, as it turns out, the culprits might just be coming from inside the house. The prime suspects, the galaxy's very own, most massive and violent stars.
The whole idea behind this is called stellar feedback. See, when really massive stars are born, they don't just sit there quietly. They are cosmic engines, just blasting an insane amount of energy back out into space and completely reshaping everything around them.
So how exactly do you punch a hole in a galaxy? It's kind of a four-step recipe for chaos. First, a whole bunch of massive stars get born together in a tight little group. Step 2, almost immediately, their intense light and powerful stellar winds start shoving all the nearby gas away. Think of it like a constant hurricane. But here's the kicker. These big stars burn out fast. So third, they go supernova, exploding in these unbelievably powerful blasts. And fourth, all those explosions going off one after another, well, the combined force acts like a cosmic snowplow, just clearing everything out and leaving behind a giant empty bubble, a hole.
Okay, so the theory sounds pretty solid, right? But scientists need proof, a smoking gun. To find it, they zoomed in on the biggest, most obvious hole in the whole galaxy. They call it the supergiant shell.
And here it is. This single void is almost 1,000 light-years across. And wouldn't you know it, what's sitting right there near the middle? A huge cluster of young stars. It's almost too perfect. They're our prime suspects. The question is, can we actually catch them red-handed?
To find that smoking gun, they needed a different kind of tool. Regular light wasn't going to cut it. Neither was radio. They had to look at the universe in high-energy light, the kind of light given off by really, really hot and violent events. They needed an X-ray telescope.
And bam, there it is. What you're seeing here is the hydrogen gas of that shell. But laid right on top of it, in red, is the data from an X-ray observatory. And look, right in the heart of the shell, a bright, powerful source of X-rays. Bingo.
Now, this wasn't just some random glow. By looking at the energy signature of those X-rays, astronomers could tell exactly what it was. It's a supernova remnant, the scorching hot, expanding cloud of debris that gets left behind after a star explodes. It's the fingerprint. It's the smoking gun we were looking for.
And when I say fresh, I mean really fresh. The data suggests that star exploded less than 2,000 years ago. On a cosmic timescale, that is nothing. It basically just happened. This is it. This is the proof that the stellar feedback engine is running right now inside that shell.
But check this out. Here's where it gets really amazing. This whole violent process, it's not just about destruction. As that shell expands outwards, it acts like a wave, piling up and compressing gas along its edge. It can squeeze that gas so tightly that it actually kickstarts a whole new wave of star formation. So the death of old stars directly leads to the birth of new ones.
It's this incredible cosmic cycle.
So, case closed, right? Big stars explode, make holes, and the edges of the holes make new stars. It's a nice, tidy story. But, of course, it's never that simple in science, is it? When researchers zoomed back out and looked at the entire galaxy, things got a bit more complicated.
The question was, does this neat little pattern hold up everywhere else? Is every single one of those 48 holes caused by a star cluster sitting right in the middle?
Well, another team did a deep dive using an ultraviolet telescope to map out all the young star-forming regions. And the results were pretty surprising. Only about 29% of new stars are actually forming on the rims of these holes where we'd expect them to be. And get this, a whopping 60% are popping up in places that have nothing to do with these holes at all.
This led the researchers to a conclusion that's, well, a little less tidy. As they put it in their paper, there's just no clear one-to-one association. It means stellar feedback is definitely a huge piece of the puzzle, for sure. But it's not the whole puzzle. There's probably something else going on, too. So where does that leave us? Why should we care so much about this one quirky, hole-filled galaxy that's 13 million light-years away? What does it all really mean?
It matters because this galaxy is like a perfect cosmic laboratory. It lets us watch, almost in real time, how stars fundamentally change their own galactic homes. We get to see this incredible cycle of star birth, death, and rebirth playing out on a massive scale. It's such a powerful reminder that galaxies aren't just static pinwheels of light. They are dynamic, violent, and constantly evolving ecosystems, sculpted by the very stars they create.
And really, when you get right down to it, the story of the holes in IC 2574 isn't just about one little galaxy. It's a window into the fundamental processes that build and rebuild all galaxies over cosmic time, including our very own Milky Way.
And it kind of leaves you wondering, doesn't it? If one single, relatively small galaxy can hold this much creative chaos and still have unsolved mysteries, just imagine what other incredible secrets are still out there, hiding in plain sight, just waiting for us to look a little bit closer.